Okay, so today what we're going to work on is the inverse of a function. So I'd like you to put me on pause and give the try this a shot, and then come back and check your answers. Okay, so we have f of x is equal to 2x squared minus 5x plus 4. We're looking for f of 3. So my input is 3. So I have 2 times 3 squared minus 5 times 3 plus 4. So f of 3, just plug that in your calculator, is equal to 7. All right, we have h of x is equal to x square root of x squared plus minus 13. So my input is 7. So it's the square root of 7 squared minus 13. So h of 7, this is the square root of 36. So h of 7 is equal to 6. All right, so let's talk about inverse. Inverse is a line reflection. So it is a reflection over the line y equals x. Okay, so if we have a graph, the line y, and we have this point here, let's say this point is -3, 2. The line y equals x is the one that's right on the diagonal here, right on the perfect diagonal, y equals x. And we would take this point and flip it over to the other side. So I would take this point and kind of like take it and flip it over to the other side, and we get 2, -3. So that would be down here. So it would be 2, -3. So that's what the inverse is. The inverse is to flip it over the line y equals x. So hopefully you remember the rule. And the rule is xy becomes yx. So x and y switch. So inverse is to switch x and y. They switch positions. And the inverse notation for a function is, it looks like f to the -1, but that means inverse. Okay, so this means inverse when you see this. It's the inverse of f of x. All right, so when you find the inverse of an equation, okay, so the first thing you're going to do is you're going to replace f of x with y. And then you're going to switch x and y. Then you're going to solve for y, sorry. And then you're going to write using the inverse notation. Okay, so let's try the first problem. Okay, so I have f of x is equal to 2x minus 3, and it says what is, so you have to know what that notation means. It says what is the inverse. Okay, so we're going to start by writing y equals 2x minus 3. Now switch x and y. X equals 2y minus 3. Add 3 to both sides. X plus 3 equals 2y. Divide both sides by 2. And we get y equals x plus 3 all over 2. And that can be written as, and it should be written as, the inverse of f of x is equal to x plus 3 over 2. And of course, this can be written different ways. It could be written as the inverse of f of x is equal to 1/2 x plus 3 halves. Okay, same thing. All right, so flip it over. Okay, so we have g of x is equal to the square root of 3x plus 2. And it says find the inverse of g of 4. So you have to find the inverse first before you plug in 4. So we have y equals the square root of 3x plus 2. Switch x and y. To get rid of the square root, you square both sides. So we get x squared is equal to, they cancel each other out, 3y plus 2. Minus 2 from both sides. X squared minus 2 is equal to 3y. Divide by 3, we get x squared minus 2 all over 3. And that's the inverse of g of x. So the inverse of g of x is equal to x squared minus 2 all over 3. So now I want the inverse of g of 4. So wherever I see an x, I'm going to plug in 4. So it's 4 squared minus 2 over 3. So the inverse of g of 4 is 14 over 3. All right, so let's try number 3. So number 3 says h of x is equal to x squared plus 2. Find the inverse of h of 6. So we first have to find the inverse. So y equals x squared plus 2. Switch x and y. X equals y squared plus 2. Minus 2 from both sides. X minus 2 equals y squared. Square root both sides to get rid of the square. So they cancel each other out. So I get y equals, now remember when you take the square root you have to have plus minus. So we have plus minus the square root of x minus 2 is equal to y. That's my inverse. So let's write it using the inverse notation. So it's the inverse of h of x is equal to plus minus the square root of x minus 2. Now I want to find the inverse of h of 6. So wherever I see an x, I'm going to plug in the 6. Plus minus the square root of 6 minus 2. So it's plus minus the square root of 4. So h, the inverse of h of 6 is equal to plus minus 2. Okay, so let's talk about a graph. Okay, so I have this function here, and it says to graph the function and its inverse. So here's my function, and I want to graph the function first. And so I'm going to make a table of values. I'm going to plug it in the calculator. I'm going to make a table of values, and then I'm going to find the inverse. All right, so this is f of x over here. So plug it into your calculator. Write a table of values. So I have negative 2, negative 7, negative 1, negative 5, 0, negative 3, 1, negative 1, and 2, 1. All right, so plot the points. So we have negative 2, negative 7, negative 1, negative 5, 0, negative 3, oops, I plotted that point wrong. One, negative 1, and 2, 1. So use the side of a piece of paper or the side of your calculator and draw a nice line for f of x. Don't freehand it like I'm doing here. Okay, and label that f of x. All right, now we want the inverse. So over here on the side, I'm going to put the inverse of f of x. You need an x column, y column. And remember, inverse means to switch x and y. So negative 2, negative 7 becomes negative 7, negative 2. I just flip-flop them. Negative 5, negative 1, negative 3, 0, negative 1, 1, 1, 2. Plot the points. So we have negative 7, negative 2, negative 5, negative 1, negative 3, 0, negative 1, 1, and 1, 2. So we'll use something straight, nice and straight. Draw your line and label that. Put it over here, the inverse of f of x. Okay, so that's how you do a graph. And we got one other thing to talk about, so just flip it over. Okay, so let's talk about identity. Identity is a composition. The identity for a composition is I of x is equal to x. So for example, if you have f of x is equal to the square root of 5x minus 3, I want to verify the composition of f of the inverse of f of x, show that comes out to be x. So when you do a composition of a function and its inverse, you should always get x, which is the identity. All right, so in order to do this, we have to have the inverse. So let's start with that. Y is equal to the square root of 5x minus 3. Switch x and y. Square both sides. So I get x squared is equal to 5y minus 3. Add 3 to both sides. And then divide by 5. Okay, so that's the inverse of f of x. So the inverse of f of x is equal to x squared plus 3 all over 5. Now I want to verify this. So it's f of the inverse of f of x. I want to show that gives me x as an answer. So it's like a question mark. Is that true? All right, so I want f. What is the inverse of f of x? That's this. So I'm just replacing. It's just a substitution. X squared plus 3 over 5. So now wherever I see an x for f, I'm going to go to my f function. Wherever I see an x, I'm going to plug in x squared plus 3 all over 5. So I have the square root of 5 times x squared plus 3 over 5 minus 3. And I don't need that last parentheses there. Just make sure that your radical goes over the whole thing. Okay, so now, so I'm multiplying these fractions here. Right, so I could put the 5 over 1, and I can actually cross off my 5s because they reduce to 1. So now I have the square root of x squared plus 3 minus 3. And then I have the square root of x squared because they cancel each other out. And the square root of x squared is x. All right, so that's it, and we'll practice more in class tomorrow. Have a good night.